Okay, we're now going to have a look at the Kim and Kanye example. So let's have a look at what we've got here. We've got Kim and Kanye balanced on a seesaw. Kim is 45 kilograms and is sitting 3.5 meters from the pivot point. Kanye, on the other hand, is just 1.5 meters from the pivot point. So always a good idea to draw a diagram to start with. So let's draw our seesaw. And obviously this point here is our pivot point. And just for your reference really, often, or you might see the pivot point also called the fulcrum, F-U-L-C-R-U-M, and also you might see torque also called moments. Okay, so there are two different ways of saying the same thing. Instead of pivot point, you might see the word fulcrum, and instead of torque, you might see the word moments. You might, as you're searching through videos and things like that, so I just thought I'd mention that. So let's have a look where we're up to. So we've got Kim. I'm just going to draw boxes because it's much easier. Kim at this end, and she is 3.5 meters away from the pivot point, and her mass is 45 kilograms. And we know that we've got Kanye sitting here at 1.5 meters away from the pivot point. It's always really good to make sure you've got a good diagram before you start. So obviously both Kim and Kanye are exerting a downward weight force. So if we work out Kim's weight force, nice and easy, 45 times 9.8, so that's 441 newtons. And we actually don't know what Kanye's is because that's part of the question. We don't know his weight force. Now, if Kanye wasn't on the seesaw, the seesaw would go down in this direction. And if the ground wasn't there, it would keep going around in that direction. So we say that Kim is providing the clockwise torque. Okay. And Kanye, if Kim wasn't on the seesaw and Kanye was on the seesaw by himself, he would go round in this direction. So he is providing the anti-clockwise torque. Okay, so that's what we mean by a torque. It's the direction that your or the seesaw here would turn, the direction that it would turn if this weight force was the only thing on the seesaw. So it would come around like this, which is the clockwise direction. Kanye, if he was the only one on there, would come around in this way, this direction. Okay, so that's how we work out direction of the torque. And one of the things that you've got written in your notes is that the clockwise torque has to equal the anti-clockwise torque for the seesaw to be balanced like this in the horizontal position. That's what we call equilibrium there. Okay, that's called equilibrium. And at that point, the clockwise torque has to equal the anti-clockwise torque. So let's work out this clockwise torque. It's force times distance. So the weight force of Kim is your 441, and she's sitting 3.5 meters away from the pivot point. Kanye, on the other hand, is, we don't know his weight force, he's just FW, but he's sitting 1.5 meters away from the pivot point. So we know the distance, but we don't know what his weight force is. Okay, but what we do know is that the seesaw is horizontal, so therefore the two torques are equal to each other. So if we work out this side, actually I haven't done it. If we divide both sides by 1.5, I've done it as one big long, 441 times 3.5 divided by 1.5 will give us Kanye's weight force. And if you work out that, you get 1029 newtons. And that is the answer to C. So let me just go back. The answer to A is actually this one here, Kim's weight force. And the answer to B is what can you say about the torques on the seesaw while it is balanced. I'll put the answer to B here. The clockwise torque equals the anti-clockwise torque. Okay, so that's your answer to A here, B here, and C here. And then lastly, what is Kanye's mass? Weight force divided by acceleration due to gravity. So 1029 divided by 9.8 will give us 105 kilograms. Okay, so Kim weighs 45 kilograms, Kanye has a mass of 105 kilograms. And that is the answer to that problem there.